Welcome to the Explainer. So today we're tackling a massive cornerstone of modern web architecture. I mean, if you've ever built a web application, an API, or a mobile app, you've absolutely run into the challenge of securely managing user identity. It's a huge deal. So today we're demystifying JSON Web Tokens, or JWTs. We're going to unpack exactly what they are, how they're constructed, and really why they've become the absolute gold standard for scalable authentication. Let's get right into it. I want to kick things off by asking you a question that honestly seems incredibly simple on the surface, but architecturally, it's actually really complex. Here it is. How does a website actually remember who you are? Think about it for a second. The HTTP protocol that literally runs the web is inherently stateless. It has zero memory. Every single time you click a link or refresh a page, as far as the network is concerned, you're a complete stranger. So how do we solve this? How are we building a continuous, secure session out of a bunch of isolated amnesiac requests? Okay, let's dive into this. Here is our roadmap for today. Number 1, the authentication problem. Number 2, enter the JWT. 3, the anatomy of a token. 4, the JWT workflow. And finally, number 5, crucial security practices. Section 1, the authentication problem, stateful versus stateless. So in traditional web applications, we used server-side sessions. A user logs in, the server creates a session ID, stores all that user data in its own memory or a database, and then just hands the client this tiny reference ID. Sounds fine, right? Well, here's the catch. As your app grows and you start adding more servers, maybe moving to a distributed microservices architecture, suddenly every single server needs access to that shared session state. It becomes a massive bottleneck. But on the flip side, we have our modern hero, JSON Web Tokens. These guys are completely stateless. All the necessary user claims are packed directly inside the token itself, which lives on the client side. The server doesn't even need to look up a session in a database anymore. It just mathematically verifies the token's signature. I'm telling you, it's a total paradigm shift. Section 2. Enter the JWT, the stateless hero. All right, so what is it? A JSON Web Token is basically a compact, URL-safe token used to securely transmit information between a client and a server. But honestly, the absolute best way to wrap your head around this is to think of it as a digital ID card. Imagine a bouncer at a club. When you hand them your driver's license, they aren't calling up the central DMV to verify your identity, right? The ID card itself has a holographic seal, like a signature, that proves it's legitimate, and your details are printed right there on the plastic. A JWT works the exact same way. It proves who you are without the server ever needing to phone home to some central database. So, why exactly have JWTs totally taken over modern web development? Let's break it down. First, like we just talked about, they offer stateless authentication. Everything is right there in the token. Second, because they are self-contained, they are insanely scalable across distributed systems. Third, they're secure by design, protected by strong digital signatures. Fourth, flexibility. You can bake custom claims, like specific user roles or tenant IDs, straight into the token. And finally, they are incredibly cross-domain or CORS-friendly. Because you send them in HTTP headers instead of relying on strict domain-bound cookies, they play so nicely with modern decoupled APIs. Section 3. Anatomy of a token, header, payload, and signature. Now, what's really interesting here is how we break the token down. If you've ever spotted a JWT out in the wild, it honestly just looks like a massive string of gibberish separated by a couple of dots. First up, the metadata. This is the header. It's basically the token announcing, hey, I'm a JWT, and here's the mathematical algorithm you need to use to verify my signature. Usually you're looking at algorithms like HS256 for HMAC or RS256 for RSA. This little piece of JSON is then base64 URL encoded, and it becomes that very first string of characters you see right before the first dot. Next up, the claims. This is the payload, basically the meaty middle of the token. This is where the actual data about the user or the system lives. You've got registered claims, which are your standard built-in data points like IS for issuer or IXP for expiration. Then you've got public and private custom claims, like a specific user ID or maybe an admin flag. And just like the header, this JSON object is base64 URL encoded and gets sandwiched right between those two dots. But please, and this is super important, note that encoded does not mean encrypted. Literally anyone can decode this payload and read what's inside. Finally, the lock that secures it all, the signature. This is the third and final piece of the puzzle. To create this, the server takes the encoded header, throws in a dot,
adds the encoded payload, and then runs that entire combined string through whatever algorithm was defined in the header. And it does this using a deeply guarded secret or private key. This mathematical signature is exactly what makes the token trustworthy. If a bad actor changes even a single character in the payload, say trying to cleverly make themselves an admin, that signature verification is going to completely fail on the server side. No way around it.
Section 4. The JWT Workflow. 5 Steps to Auth. Let's look at this digital ID card in action. Here is the exact 5-step chronological journey of a JSON Web Token. Step 1. The user initiates a login, sending over a post request with their email and password. Step 2. The server verifies those credentials against its database. If everything checks out, the server generates the JWT, signs it with its secret key, and hands it back. Step 3. The client securely stores this token. Ideally, you want this in an HTTP-only cookie to heavily defend against cross-site scripting attacks. Now, step 4 is where the magic happens. For every single subsequent request, the client sends that JWT along, usually right in the authorization header using the bearer schema. And lastly, step 5. The server catches that request, extracts the token, verifies the signature using its secret key, checks to make sure it hasn't expired, and boom, grants access. Zero database lookups required whatsoever.
Section 5. Crucial security practices.
Okay, so JWTs are incredibly powerful, but with all that stateless power comes some pretty massive responsibility. I really want to pause here and emphasize a quote directly from our source material. Never put sensitive information like passwords inside a JWT payload. I literally cannot stress this enough. Like we talked about during the anatomy breakdown, the payload is merely base 64 URL encoded. Anyone who intercepts the token, or even just pops open their browser's developer tools, can decode it in half a second. Remember, it's an ID card, not a locked safe. You have to treat the data inside it as completely public information. To make sure your implementation is absolutely airtight, here is your essential JWT security checklist. First up, always transmit over HTTPS so your tokens can't get snatched in transit. Second, you have got to guard your secret and private keys with your life. If those leak, anyone can forge a perfectly valid token. Third, explicitly configure your servers to reject any tokens with the algorithm set to none. That's a notorious vulnerability in older libraries that basically just bypasses signature checks entirely. Fourth, diligently validate your standard claims, especially that expiration time. Fifth, since tokens are stateless, you want to use really short expirations, like maybe 15 minutes, and pair those with longer-lived refresh tokens. And lastly, store them securely on the client side, heavily preferring HTTP-only cookies for web apps to block those nasty JavaScript-based attacks. As we wrap up, I want to leave you with a bit of a provocative architectural question to chew on. The absolute greatest strength of a JWT is its statelessness, right? But ironically, that's also its biggest challenge. Since a JWT cannot be easily revoked by the server once it's out there in the wild, how will your specific system handle a compromised token? Are you going to rely entirely on short expirations, or will you maybe introduce a token blacklist, essentially sacrificing a little bit of that statelessness for the sake of security? Understanding those exact trade-offs, well, that's the mark of a truly great systems architect. Thanks so much for joining me for this explainer on JSON Web Tokens. Take these concepts, lock down those security practices, and go build some amazingly scalable systems.